Welcome everyone to my final presentation on the automated fraud detection system. My name is Avinash and today I will walk you through the project that I have been working on this course. Let's get started with the agenda for today's presentation. Here is the agenda for today's presentation. We will begin with an introduction of the project, followed by the discussion on the business and technical requirements. Next, we will look at the use case and user stories, then move on to the description of the diagrams included in the project. We will also discuss key concerns identified during this project evaluation. Finally, I will provide a summary of the project. The project is titled Automated Fraud Detection System. The main objective of the project is to enhance the efficiency of fraud detection process. I aim to achieve this by implementing machine learning algorithm that can automatically identify suspicious transactions and alert the fraud prevention team. Let us discuss the business requirements. One of the primary goals is to reduce the manual efforts required by the fraud investigations team. This means minimizing the time analysis spent or analyzing the fraud detection patterns. Another key requirement is to improve the accuracy of fraud detection. By enhancing the precision of our system, we can ensure that fewer false positive and false negative occurs, thus increasing the overall reliability of fraud detection process. Moving on to the technical requirements. The system needs to be capable of real-time data processing. This is essential to detect fraud as it happens and preventing further damage. High scalability is also crucial. The system must be able to handle high volume of data transactions without any drop in performance. Lastly, strong security measures are needed to protect sensitive user data for unauthorized access and breaches. Now let's look into use case. The first use case is detecting fraudulent transactions. In this scenario, the system scans incoming transactions and flags those that appear suspicious based on predefined criteria. The second use case involves system alerts for fraud detection. Here the system generates alerts for the fraud prevention team whenever it identifies potential fraud, enabling quick investigations and actions. Let's explore the user stories. For fraud analysts, the system should automatically flag suspicious transactions, allowing them to focus their efforts on reviewing and taking appropriate actions. For members of the fraud prevention team, receiving timely alerts for potential fraud cases is crucial. This enables them to promptly investigate and mitigate any fraudulent activities. This slide provides an overview of key diagram included in the project. Each diagram will be explained in detail in the following slides. Sequences of operation, class structures, and data flow within the automated fraud detection system. The business process model is represented by the swim lane diagram. It outlines the flow of activities across different lanes, representing various stakeholders involved in the process. The swim lane represents different entities such as the data systems, fraud protection models, and fraud prevention teams. Key activities include collaborating transactional data, analyzing data for fraud patterns, generating alerts for suspicious transactions, and investigation flag transactions. The use case diagram provides a high-level overview of the interactions between various actors and the system to manage fraudulent transactions. Primary actors include data systems, fraud detection systems, and fraud prevention team. Key use cases involves feeding transaction data into the system, processing transaction data to predict potential fraud, analyzing data for fraud patterns, and generating alerts for suspicious transactions. This diagram helps in understanding the functional requirements and interactions within the system. The sequence diagram illustrates the interactions between various components of the system to detect and manage fraudulent transactions. Components include data systems, fraud detection systems, which also compromises the fraud prevention model and fraud prevention team. The diagram shows the flow of messages and actions from collecting transaction data to analyze it, generating alerts, and reviewing alerts by the fraud prevention team. Key actions include data collection, fraud prediction, alert generation, and investigating the fraud transactions. This diagram helps in understanding the dynamic behavior and sequences of operations in the system. The class diagram represents the system structure by showing its classes and the relationships among them. Key classes include transactions, fraud prevention models, alert, and fraud prevention team. Relationships are depicted through associations, aggregations, compositions, and dependencies. This diagram illustrates how data is managed, analyzed, and utilized within the system to identify and prevent fraudulent activities. The diagram helps in understanding the static structure and data organization of the system. Now let's talk about the data flow diagram, DFD. This depicts the flow of data through the system. Key components includes external entities, which are user and fraud detection system. The processes include collect data, process data, fraud prediction model, general alerts, and review alerts. And the data stores are transaction data store, alerts data store, and review data store. The DFD shows how transaction data is collected, processed, analyzed, and reviewed to detect and prevent fraud. It provides a detailed view of the system's data flow and interactions, helping in understanding how data moves and is transformed in the system. During the project evaluation, two important concerns were identified: maintainability and sustainability. Maintainability is crucial to ensure that the system can be easily updated and new fraud detection algorithms and bug fixes can be done. Scalability is necessary to handle increased transaction volume without compromising system performance. To summarize, the automated fraud detection systems aim to enhance fraud detection efficiency through machine learning. The key takeaways include the importance of maintainability and sustainability, as well as implementing strong security measures. Looking ahead, further enhancement could include further refining the fraud detection algorithm and expanding the system's capability to cover more types of frauds. Below are the references that I used for the research and development of my project. Thank you, class and professor. I hope you found this presentation insightful. I'm looking forward to your peer responses. Thank you so much and all the best.